In Project 5-4, we will be partitioning the hard drive. This is particularly dangerous. So in Oracle VirtualBox, we want to make sure that all of our snapshots have been merged, and then we want to take a snapshot of our CentOS 7. So click on the Snapshots button, click on Take Snapshot, and name this one Before Project 5-4, and hit OK. Once the snapshot is taken, you may bring up your virtual machine. And before we dive into partitioning, I want to bring up a few points. If your hard disk is less than 2 terabytes, the standard partitioning is MBR, which stands for Master Boot Record Style Partitioning. It has a maximum of 4 partitions, one of which can be extended, the others can be primary. Now you could have 4 primary partitions and no extended. The normal setup is to have 1 or 2 primary partitions, the rest of the drive an extended partition, and the extended partition can be broken up by the operating system. The number of partitions inside it are limited by the software, and they are called logical drives. If you have greater than a 2 terabyte drive, you will use GPT style partitioning. The max partitions are basically unlimited. It is only limited by the operating system. For Linux to boot, you have to have a separate partition called /boot/EFI. And for GPT to work and for you to boot an operating system, the BIOS must be 2010 or later and support UEFI. Intel started working on GPT in the late 90s. However, it was not included into operating systems until 2010, I should say into motherboards. For more details, you should use Google and search for the difference between MBR partitioning and GPT partitioning, especially if you're going to install a new server or new computer and have to deal with partitioning the drive. Now, let's dive into partitioning our drive. We'll hit Ctrl-Alt-F2, log in as the root user. Since this is going to be messing with our system, you have to have full administrative rights. Now, we will issue the fdisk command, space, and the device that we're going to operate on. So that is under the DEV directory, / and our hard drive. Most hard drives are SATA or SCSI drives, so they start with an S, and then they have D, stands for disk, so we have a SATA or SCSI disk, and then the letter after it will specify which drive in the system. We have A through however many drives that you have in your system. Of course, the first hard drive will be A, the second hard drive that you would have plugged into the system would be B, and the third C, and so forth. When we hit enter, the fdisk opens up. It does tell us we can hit M for help, so that's useful. We'll type M, hit enter, and here's a list of commands that we can do. Notice we can print the partition table, we can add a new partition, and you can also delete partitions. And then the last one is write. Those are the most common options for the fdisk command. Let's start by typing P to print the current partition table. You should have a screen very similar to mine, where your SDA1 is where your root file system is. All of your files we've been messing with are on that partition of the hard drive. You should also have a swap partition, and then we should have some extra space that we can create more partitions for this lab. Now let's create a new partition by hitting N. It comes up and asks, do we want a primary or an extended? The lab wants us to create an extended, so we'll hit E. When you create an extended, it's best to take up the rest of the hard disk space, because you can only have one extended and a maximum of 4 primaries. So we've already have primaries, so our best bet is to create an extended to take up the rest of the space. The partition number, we'll select 3. The first sector, we'll go with the default. And the last sector, again, go with the default. Your numbers should be very similar to mine. If your first and last values are close together, then you may have taken the entire drive up instead of partitioning it as in the installation video for chapter 2. If you have no space, you could go into machine and settings, go to storage, and add another hard drive. You would have to do this with the CentOS shut down. And you add a second hard drive of say 30 or 60 gigabytes. Then you can start CentOS again, and instead of DEV/SDA, you would do DEV/SDB. But hopefully you partition it correctly in Lab 2, and we have around 28 gig of space to play with. Now let's look at our partition table by hitting P again. We see our extended partition has been created. Next, we will create a logical drive inside of the extended. It wants us to create a 1 gigabyte logical drive. So we'll hit N on the keyboard for new. It asks us, do we want to create primary or logical? There's no space left on the drive, so we have to create a logical drive inside the extended partition. You typically cannot boot an operating system off of a logical drive because only the operating system knows how the extended partition is broken up. That is why it is called logical drive, because the OS has to load into memory to be able to read how the extended partition is broken up. The BIOS on the motherboard cannot see that. It does not have the code or knowledge of what operating system you've installed on your computer. It can only see primary partitions. So here it's asking for first sector. We will hit enter for the default. Now it is asking for last sector or size. So it shows that we can put in a plus 1 G. Hit enter. Partition of 1 gig has been created. If we hit P to print the partition table again, we will see our logical drive. Note it is SDA 5. Any logical drives start at number 5 or higher. Because as stated, MBR can have 4 primary or 1 possible extended partition for a total of 4 partitions on the entire drive. So the 4 partitions that the BIOS can see are numbered 1, 2, 3, and 4. Anything that's logical that requires an OS to be loaded to view them is labeled 5 and higher. Now if we hit M for help, we see that we can type W to write the table to the disk and exit. Let's go ahead and do that now. So we have created it. It tells us we can run part probe to reread the partition table into RAM. Otherwise, you would have to restart your system. So we'll run part probe. In some Linux distributions you may get an error and you may have to restart the system. Now I'm going to check to make sure the partition table is visible. I'll use fdisk -l space /dev/sda to make sure that we can see all of the partitions. Before you can use a partition, you must format it. There's a make file system command, mkfs. There's the -t option. You could format this as several different ways. VFAT is a common way to format USB drives, 32 gig or less in size. It's a standard Windows partitioning. And there's many other file system types you could format as. The lab wants us to be ext4. Specify the /dev sda5. We do not format the extended partition. You only format the logical drives that are inside the extended partition. Extended, again, is just a placeholder so that you can break up that space via software and then format the logical drives inside of it. Once formatting is done, we now have to mount that file system into the Linux tree. Windows typically assigns a drive letter such as D, E, or F to a new partition or a drive that you plug into the system. Linux, you have to create a directory and mount the partition. Let's make a directory, putting it under the root, so we have to put a / new mount. Make directory / new mount. I'll do ls space / to verify that I see new mount under the root directory, not the root home folder. Now I'll mount the directory. There's a -t, and you can specify the file system, such as ext4. If you are unsure of the file system, I like to use the word auto, and it will scan the drive and try to figure out what file system to use. And then I'll put / new mount and hit enter. I forgot to put the device to mount. The logical drive, if you remember from fdisk, showed up as /dev / sda5. Now if I look at that new file system that is mounted under new mount, I'll see there's one folder in there called lost and found. It's a recovery folder. If for some reason an application was trying to save a file in the middle of a power failure, the file may not be correctly written to the drive, so pieces of it will be found on the next reboot or next file system check, and the data will be put into the lost and found folder. If we were to restart the computer, the file system would not automatically be mounted. We have to specify that the file system is mounted. I'm going to clear my screen, and I'm going to use the vi command to edit a text file under /etc /fs tab. So file system tab file, meaning each value should be tab separated. In this file, there are already two partitions, and they use a UUID number that is very complex and hard to read. I prefer to use the device /dev /sda and partition number, but the OS uses a slightly different form. So let's go to the last line, arrow down, hit I, to get into insert mode. And then you may hit end on your keyboard, the END, to get past the very last 0 in that line. I'll hit enter and make sure nothing is split. You could easily break something here by not being at the very end of the line. So again, I hit I on the keyboard, arrow down, and then hit end on the keyboard to get to the very end, or you can use your right arrow key. So make sure when you hit enter, nothing gets below the underscore. Here I'll put the device, SDA5 that we created, and again, FS tab, meaning the values must be tabbed, separated. So I will hit tab. Next, it wants to know what folder do I mount SDA5 to. The folder we created, /new mount. I'll hit tab again. It wants to know what file system, ext4. Tab, I'm going to use the word defaults. Sets default information like a read write and different type of options on the file system. Normally safe to use default. And then I'll use 0 space 0. That deals with, can the drive be backed up or not, and should the drive be checked after so many restarts, and in what order should the drive be checked. We're going to zero those out for now. You can research those if you need to do backups or if you're worried about a corrupt file system. ext4 typically does not need to be checked if a power failure happens. So we will zero that out. Now hit escape on the keyboard, type :WQ to write and quit. Here I'll type in clear, and I'm going to type the word mount. I see that my SDA5, the very last line, is mounted on new mount. I'm going to type umount /new mount. I will hit enter. I'll type mount again to make sure that I do not see it on the last line. And to test to make sure that my FS tab file is fully functional before I reboot, I will type mount space -a, hit enter. I don't see any errors. I'll type mount again and hit enter. I now see SDA5 is mounted on new mount. So without any errors seen, I should be able to safely reboot my Linux system, and everything should come back up. And when I log in as root, if I type mount, I should see the same thing, /dev/SDA5 on new mount at the very end. You should try that, and don't forget your screenshots in this lab. And after you reboot, if everything is working properly, you may delete the snapshot before moving on to the next project.